Now I've taken all the air of this chamber and I've sealed it off with this valve, and I can unplug this now. And now as I drop them, they both fall at the exact same rate. They both hit at the exact same time, showing that without air, again, all objects fall at the same rate, about -10 meters per second each second. So now let me go ahead and let the air back in this thing so I can open up this valve. Now, notice the fall rate again. Again, the penny hits quite a bit before the little piece of cotton. All right, let's go ahead and go back to my demo, or to my lecture. Okay, now, when we graphed our egg drop, we had three different graphs. We had y versus t. Now, make a note, it's not x versus t anymore because in the Cartesian coordinate system, when we have two planes, we devote on the forward and back plane is x, and the up and down plane is y. So now we're dealing with free fall, objects that are falling, so we're dealing with the up and down plane. So I call it y versus t. So specifically for our egg drops, we have, back to our normal, our usual suspects from last unit, y versus t, v versus t, and a versus t. And our y versus t slope down like this. Our v versus t started at 0, is at the top of a drop. You start at 0 and then you increase in the negative direction. That's negative slope, so our a versus t looks like this in the negative direction. That's our basic graphs for free fall. Right, we already did this demo. Do objects of different mass fall at the same rate of acceleration? And the answer is yes, with an asterisk. The asterisk is when there's no air, when you're actually lacking air. We did those two demos already. Okay, so there you go, there it is. The absence of air resistance, objects will accelerate at the exact same rate. So now this brings us to the Wile E. Coyote example problem in the notes. So you have to flip to the end to find this. I need to stop for real quick.